In 2 dimensions, you're likely familiar with the equation for a hyperbola. It describes a relationship between x and y coordinates, a rule that every point on the curve must follow. For any point x, y on this shape, the value of x squared over some constant a squared minus y squared over b squared must equal exactly 1. This simple rule carves out these 2 iconic opposing branches in the plane. The constants, a and b, just control how wide or narrow the curve is. For instance, the curve will cross the x-axis at plus and minus a. But now, let's ask a question that's core to thinking in 3D geometry. What does this same equation represent not on a flat plane, but in 3-dimensional space? To think about this, we first need to introduce a third axis, the z-axis, coming straight out of the screen. Our equation, notice, puts a strict condition on x and y, but it says absolutely nothing about z. The variable z is completely absent. What does that imply? It means that for any value of z you can imagine, whether z is 0 or 5 or -10, the relationship between x and y must still hold true. So if the same hyperbolic cross-section must exist at every possible height along the z-axis, what shape do we get? Well, we can visualize this by taking our original hyperbola in the xy plane and stacking infinite copies of it, one on top of the other, stretching all the way up and down the z-axis. When these infinite copies merge together, they form a continuous surface. This surface is what we call a hyperbolic cylinder. The hyperbolic part describes its cross-section, and the cylinder part comes from the fact that this cross-section is constant along one axis, in this case, the z-axis, which is the axis corresponding to our missing variable. Let's make this concrete with an example. Suppose we need to sketch the surface given by x squared over 4 minus y squared over 9 equals 1. First, we look at the xy plane. Here, a squared is 4, so a is 2, and b squared is 9, so b is 3. This gives us a hyperbola that crosses the x-axis at +2 and -2. Now, we notice the equation is missing the z variable. This is our cue. It tells us that this hyperbola shape is simply extended or extruded infinitely along the z-axis. And there you have it, the graph of our specific hyperbolic cylinder.